Sir, I am K. Nitish from Mechanical third year. My top roll number 24955 A0306. My topic is about fundamentals of training, validation, and testing process in supervised learning. Supervised learning is a model learning learns a mapping of from input features to output labels using labeled parts. To build a reliable model, the dataset is divided into three parts: training set, validation set, test set. So, supervised learning is a type of machine learning where a model is trained using labeled data. Each inputs are a corresponding correct outputs. Defining supervised learning is a process of learning a map mapping functions like f of x to y. F of x is input features, v is known output, that is labeled output. Key dataset splittings are of typically the data splitting is training data is set is 60 to 80%, validation set is 10 to 20%, test data is 10 to 20%. Example, if we total data is equal to 1000 samples, training is equal to 700, validation is equal to 150, testing is also 150. So the key ideas is the model learns from the examples with answers. Like a student learning with a teacher, that teacher provides the questions inputs and also provides the correct answers, that is labels. Types of types of supervised learning classification. Output is categorized classes, examples spam or not spam, disease not disease, cat or dog. That is categoristically means yes or no, neither yes nor no. Like you can tell the example like yes or no, true or false, spam not spam, disease no disease, cat or dog. Algorithms used in supervised learnings are logistical recursion, decision tree, support vector machine, Navy base. Recursion output is continuously numerical. Example: house price prediction, temperature prediction, stock price estimation. Logarithms used are linear recursion, polynomial recursion, Riddler recursion. Work process is work process is collect. Now we come to know about the working process is step by step is like that is collecting the labeled dataset, splitting into training, validation, and testing, training model to train data, adjusting model using validation data, evaluate using test data. Advantages are high accuracy with if enough labeled data, easy to validate performance, well understanding and widely used. Disadvantages are requires high label data. Labeled data can be expensive and time consuming, may overfit if not properly. Applications are ma- mail spam detection, image recognition, speech recognition, medical diagnostic, fraud detection. Next is important concepts are overfitting, underfitting, generalization. Overfitting memorizes more data. Underfitting fails to learn. Generalization performs well with new data. Now we come to know about the learning training process. The purpose of training set is to teach the model. Process is that input features are fed into the model. Model predicts output. Prediction is compared with actual label. Error is calculated using a loss function. Model parameters. Model parameters are updated to reduce errors. Common algorithms used are linear recursion, decision tree, neutral networks. Now we come to know about the loss function. Loss function measures how far predictions are can be actual values. Example, mean square error. Mean square MSE is equal to 1 by n arithmetic y minus y square. Y is equal to actual value. Y is equal to predictive value. A training set is a portion of data used to teach the model how it works and provides the input features like X, output labels like Y. The model makes prediction, compare prediction and actual labels. Update is internal parameter to reduce error. Key ideas is the model learns patterns and relationship from this data. Example, if you are predicting house prices, input is size, location, room. Output is price. The model learns how it effective. Next is validation. Validation is a set of that set. It is used for evaluate the model during train and tune it. The purpose is that validation is used to tune hyperparameters, prevent overfitting, select select the best model, select the best model, select the how it works. Model trained by training set, evaluated by the evaluated set, performance is monitored. Hyper Hyperparameter tune, learn rates, number of layers, depth of tree, regulation parameters. Why it is used? Why it is needed? If we use if we use only trained for dataset, the model may overfit, memorize instead of generalizing. The key uses of it are model selection, hypertuning. Key idea is to help and ensure the model generalize well with unseen data. Next is testing Next is testing performance. The testing is used for evaluating the final model performance. Test test data is never used during training or validation. Provides unbalanced. Next is Next is model evaluate matrix. For classification, accuracy, precision, recalling F1 scores. For recursion, MSK, RMSV, R square scores. For cross validation, instead of a single split, k-fold across validation is used. Data divides into k parts. Model trains k parts, each time using different parts of validation. Important important of the process is ensure model generalization, prevent overfitting, help the model select help in model selection, improve realization. Workflow summary is to fitting datasets into training, validation, testing, learn model on train set, validate dataset, tune hyperparameters, finalizing model, evaluating the trained dataset. Some of the practical examples are, suppose we are predicting the house prices. Training set is learning relationship between size and price. Validation set is tuning model parameters. Test set is checking how well model predict new house. So I hereby conclude that supervised learning is a fundamental and widely used machine learning approach in which models are trained using labeled sets to learn the relationship between the inputs and outputs by using structured process such as training, validation, and testing. It ensures the model not only learns effectively but generalize how to will to new unseen data. It is effectively solve both classical and recursion problem, make it suitable for a wide range of real world application like predicting, diagnosing, and decision making. Cares must be taken to avoid issues like overfitting. Thank you.